Hello students, in this video I am going to talk about conductance of electrolytic solutions. Conductance of electricity through electrolyte solutions. Electrical resistance represented by a symbol R. Resistance R of a solution is directly proportional to the distance L between the electrodes. Resistance is directly proportional to the distance between the two electrodes. Okay, the distance is represented by L. And resistance is inversely proportional to the area of cross section A. So resistance is inversely proportional to the area of cross section of electrode. Okay, each electrode and represented by symbol A. Okay, so it is expressed R is proportional to L. R is directly proportional to L, which is distance, and inversely proportional to area of cross section. So 1 by A it is. So R is proportional to L by A. Okay, and R, which is equal to proportionality constant, proportionality symbol is removed by adding constant called rho into L divided by A. And this component or quantity L by A is called as cell constant. Quantity L by A called as cell constant. The unit of resistance is ohm. Okay. The constant of proportionality rho RHO is called resistivity or specific conductance. So the rho is called as resistivity or specific conductance. The unit of resistivity or specific conductance is ohm meter. It is represented as ohm meter. But often used ohm centimeter. Often resistivity is expressed in terms of ohm centimeter. Resistivity or specific resistance defined as the resistance of a solution placed between two electrodes having an area of 1 square meter each and placed 1 meter apart. So resistivity is defined as resistance of a solution. So when two electrodes are placed between a distance of 1 meter, and if electrodes are having area of cross section of about 1 square meter. So therefore resistivity is defined as a resistance of a solution placed between two electrodes having an area of 1 square meter each and placed 1 meter apart. So inverse of resistance R is called conductance. So it is expressed as G, which represents conductance, equal to 1 by R. We said inverse of resistance is called conductance. Inverse 1 by R. Inverse of resistance 1 by R equal to conductance G. And we know the formula for R, that R equal to L by A. So if you substitute here R, which is equal to L by A. So the A in the denominator will move to numerator. So therefore it is equal to A by rho into L. So 1 by rho is equal to K. It is also proportionality constant. So rho is our proportionality constant and it is resistivity. So 1 by rho is K and it is conductivity. So SI unit of conductance is Siemens, represented as S. So S is equal to per ohm. also known as, it is represented by the symbol per ohm. Inverse of resistivity 1 by rho, which is equal to conductivity. It is also called as specific conductance and represented by a symbol K. Unit of conductivity is Simon per meter, but more often it is used or it is expressed as Simon per centimeter. So conductivity or specific conductance is defined as conductance of a solution placed between two electrodes having area of 1 square meter each and placed 1 meter apart. Conductance varies from metal to metal, or conductance varies from one material to another. So it depends on the nature of the material and temperature and pressure. Conductance depends on the nature of the metal or nature of the material, temperature and pressure. So depending on the conductivity, a metal or a material is classified into 3 types. First one is conductors, second one semiconductor, third one is insulators. Conductors are the materials which show large conductivity. Semiconductors which show some properties of conductors and some properties of insulators, or we can say, so conductivity is in between conductors and insulators. So for example, silicons, doped silicon, gallium arsenide. Insulators which show very low conductivity property. Examples: glass, ceramics and etc. Superconductors, as the name indicates, which show infinite conductivity with zero resistivity. Superconductors show infinite conductivity and there will be zero resistivity. So metals and their alloys at low temperatures shows superconductors. But nowadays, ceramic materials and mixed oxides at temperature as high as 150 Kelvin, so it will exist as superconductors. So earlier, metals and their alloys at low temperature between 0 to 15 Kelvin existing as superconductors, but nowadays, so up to 150 Kelvin, ceramic material and mixed oxides shows the properties of superconductors. Thank you.